Hello, we're going to start looking at XML, which is the extensible markup language. And I kind of enjoy this technology. It's a lot of fun. And particularly, I use the XSLT, which is part of this that we'll get into. So let's start by just looking at how the XML works. It's derived from an older markup language called SGML. You'll notice right away that it's very similar to HTML, which is derived from it. So it uses the elements with the less than, greater than tag style that we've seen. XML is really important. It's used for data interchange extensively in the industry, and so it's a good thing to know, and I think you'll find that it's a useful thing to have in your IT toolbox. So what can we do with it? We can move data between systems easily. We can squash binary objects in XML representations, preserve their state. We can even move them across the network and then revitalize them. So that's a way of doing a kind of distributed computing. We can use some XML technologies, XSL and XSLT, so that we can transform and style our XML content pretty much any way we want. So XSL is extensible style sheet language, and XSLT is the extensible style sheet language transforms. And this is a really powerful way to take data from an XML format and translate it into any other format, including other file types. So I can translate to CSV, so I can read it into Excel. I can translate into JSON markup, so I can read it with JavaScript. And these are all things that are fairly easy to do, and I do these routinely in my own work with web development. We also have a series of XML languages which follow the basic rules of XML, and they have their own set of elements. And one of those is MathML, which is useful for displaying advanced math notations like derivatives and things of that nature. Excuse me. One that you're going to learn in the Fundamentals of Web Development class is called Structured Vector Graphics, or SVG. And this is an easy way to create production graphics and logos and things like that without using any programming. So it's a declarative language which has graphics primitives, and we'll get into that in some detail. HTML5 now supports that. You can put the SVG directly in your HTML5 documents. There's another language called Smile, and the SVG now incorporates part of that. That's a way to create animations with XML markup, and you can synchronize multimedia. So that stands for Synchronized Multimedia Integration Language, which means basically having animation and graphics and sound, audio, and synchronizing how they play together. And we won't get into that. That's pretty advanced, but there is some animation now from that that's moved into the SVG that we'll learn. Another XML format that's used, which we will look at, is the RSS, really simple syndication, which is mostly used now for blog sites and sites that publish their content. So the idea here is when you have a site that has a great turnover with a lot of content, you can advertise to the people that subscribe to it, and then they'll know when there's new content. Finally, one of the reasons we're getting into this is now HTML5 allows us to embed the XML directly in our web documents, especially the SVG. So that means we can create graphics that have a very low imprint on the bandwidth because they're mathematical descriptions rather than bitmaps. So this is a really important technology. I'm really fond of it. We'll do about 2 weeks of it here in the Web Fundamentals class. So the syntax for the XML is similar to what you learned in HTML5. And it does add a requirement that the XML has a single root level container that contains the entire document. Well, actually, we have that in HTML, right? Because the HTML tag contains, or element contains the entire document. So the basic rules are that all elements have to be well formed. They either have to have a closing tag that matches them, or they have to have the special singleton style tag that we've seen. And then we have to have tags properly nested. So one tag has to be completely within another. It can't start within and end outside of. So you know this already. Here's our XML basic structure. We have the version number. That's been one for now for about over a decade. It probably won't ever change. We have a character set, which is optional here. And then you'll see that we have the root element family, and it has 3 child nodes or child elements, dad, mom, and boy. And if we look, the dad node has the value of Homer. So again, the dad element or dad node is a container, and its content is the text, Homer. The mom node has a container value of Marge, but it also has an attribute, and this is age, and it has a value of 32. Again, you've seen all this in the HTML, so it's pretty straightforward. Finally, we have a special singleton element here, boy, which basically is an element with no content. And although some of the tools will represent it like this with the special slash ending there at the end, you can also write it like this with an opening and closing tag, and those are considered equivalent. Okay? So again, we have the XML header. The only part of this required is just the first part with the version there. And then we have a root element, and then we have a series of child elements in there. This is really simple. The child elements themselves could have elements as well, but they don't here. As we get into it further, you'll see a more elaborate example. So XML documents can be standalone, or they can have what's known as a document type definition, a DTD, or a more modern thing known as a schema. And so what the DTD and the schema do is they define a class of documents. And so the common standards that we use have these. The DTDs are older, and basically they're still around now because some of the standards we use were implemented with them. But in modern work, you just use the schema instead. Now, the rules for generating these schemas and DTDs are quite complicated, and that's really beyond what we cover here in the course. I basically just want you to know what they do and enough syntax to know how to hook them up into a document. So I can have a standalone document that just follows the rules for well-formedness. All the elements are closed. Everything's in one root element. We have the header. We don't have any improper nesting of elements. And then that'll work, and the parser will display that. Unlike HTML, where the parser is fault tolerant and it'll try to display any markup no matter how crappy it is, XML is the reverse. The XML parser is absolutely not supposed to show you a bad document. It's supposed to show an error. So this is a little bit more anal than what we've seen with our web browser and the way our web documents are displayed by the browser. Okay? Again, the DTDs and the schemas define types of documents that are formal, and that's very useful. For instance, if we're going to exchange documents with another company, then we have a tool that can verify that the document is well formed and matches the rules from the DTD or the schema. Okay, there's a variety of XML software tools. You can use the web browser to view the XML. If you want to edit the XML, it's a plain text file, so you can use any plain text editor like Notepad or even WordPad in text mode. Of course, it's a little easier if you use an integrated development environment like Visual Studio, Eclipse, NetBeans, or Aptana Studio. I forgot to mention it here, but Dreamweaver works fine for editing XML documents too. Since I've kind of gotten on a kick of using NetBeans now for my web development, in the video examples that I'm going to make, I'll be using NetBeans. But you can use Dreamweaver just as easily. You can also just go ahead and use Notepad if you want to write everything out by hand, or you can use one of the other IDEs. Validators are programs that check the XML document against a schema or DTD. In fact, that's exactly what the W3C validator that you use to check your HTML5 documents or the validator within Dreamweaver do. So there's nothing new there. So we can use a validator to check an XML document when it does have a schema or DTD. We probably won't do too much of that here. I just want you to know about it and how it works, okay? But again, I'm not going to ask you to write a schema or DTD. We won't use those too often. XML is really ubiquitous now, and so almost all the standard tools support XML import or export. You can use Office. You can save all of the Office documents now in XML format. The SQL Server and the other database servers will allow you to export a query as XML. Tools like PowerShell work with XML. And so again, it's a very ubiquitous file format. Okay, one of the things we have that we haven't encountered in HTML is namespaces. And so we're going to look a little bit further at some of the specifics for creating the XML documents and the basic rules for these. So again, a document is well formed if all the tags are closed or they're empty and they have the special empty slash at the end, and if they're properly nested, and then all the attributes have values which are quoted. And then again, the entire document is one root element. So that's well formed. So here's a document header. We saw this before in the example. And again, the only part that's required is this question mark XML version equals 1.0. And you know what? It looks like we have a typo here. This question mark should be here at the end, not there at the beginning. So sorry about that. Let me fix that real quickly here just to make sure that I'm clear about what the problem is. So this should go right here at the end. And this, the question mark only occurs in the heading here. So this is the header of the document. In this case, let's see here. So in this case, we have an encoding of ISO 88591. That's a European character set that allows for umlaut characters and acute characters and gravs and things like that. I use that in my Norse work. More common, we're going to have UTF-8 or UTF-16. You can also have a standalone here. That means that there's no DT or DTD or schema. That's usually not put in there though, because the information to connect the DTD or the schema simply isn't there. So most people don't bother with that. But when we talk about a standalone document, that means one that isn't connected to a DTD or a schema, either because we have this or because we simply don't have any connection. Okay, I started to talk about namespaces a second ago. Basically, a namespace allows us to specify our references. And these kind of work like the mechanism in Java that uses for referencing libraries. So let's think about the idea of a title. So the title in the realm of a person can mean something like Mr., Mrs., Ms., Miss, Doctor, Father. Those are all titles. But in the realm of a book, a title has a totally different meaning. And so we can use the namespace to disambiguate which title we're talking about, the title for a person or the title of the book. So the namespace, pardon me, is the person or the book, okay? So we have a mechanism here in XML where we use this. And so if we look at this, pers : title, This is the person namespace, and that means the title from that namespace. And book title means the title from the book namespace. Okay. Now, this isn't going to come up all the time, but it turns out it's going to be very important when we do the SVG because we'll be using some existing namespaces and we'll have to specify that. So as we get more into that, I'll explain that, but you should know now what the namespace does, and I'm going to show you the mechanism for it here directly. So here's how this works. This slide is somewhat abbreviated. So on the first line, we would have the XML declaration, which would have the less than, question mark, XML version equals 1, etc. And then here we have the definition for a namespace. So this XML NS means namespace, and it's defining the namespace to have the prefix of PERS. So PERS person says, okay, here's a namespace called person, and its prefix is PERS. Okay? And then this is going to be a URL, which might or might not be actually valid. It might just be a unique identifier like we do in the Java libraries to prevent a conflict, or it could be an actual URL with a working definition of a type of namespace and a type of document. So here you can see that we have title in the namespace of person, and then that's Mr. And then we have person name, and that's Bill. And so here we're basically fully qualifying this. So in each case, we're always saying what namespace it is. Now, we don't have an example of the book namespace in here, but we'll see that in a second, okay? So once we define the namespace, we can use it in any of the descendant content in the document. And so usually we're going to put this in the root, and then we can use it anywhere in the document. So again, this would be in the root of the element right after the declaration. Okay, let's make this a little more complicated. So here we have an XML namespace called person, and then we have another XML namespace, BK, which is short for book. And I think we might have some missing information here. So I think this probably should say BK : book, and then XML namespace BK equals URL like this. So basically then we would have two namespaces, and since they're both defined, we have to use them fully. So later on in a minute, I'll show you that we usually have a default namespace so we don't have to use the prefix here. So now if we look in this, and again, I'm pretty sure that basically what's missing here is the, this should be book : BK space. Okay, so that defines the book. Oops, I'm sorry, I did that backwards, didn't I? Okay, so it should be the prefix BK and then the name of the namespace, which is book. Let's go ahead and put that on the next line so we can kind of line them up there so we can see. So we have two namespaces, and now this means the title in the person area, but down here, Bill has the name of his book called Life Sucks, and that's a title, and that's from the book namespace, okay? So you can declare more than one space, and this really shows you how we use the two namespaces or multiple namespaces to disambiguate things. So again, I have a title in the realm of person, that's like a person's title, and then I have a title in the realm of a book, which is simply the name of the book. Okay, I hope that's clear. Sorry I had to fix the slide there. Okay, now here's how the default namespace works. So if we do this, person, and we don't have a prefix, this is going to be a default namespace. And then again here we have the other one. Again, this is wrong. Let me fix it one more time. This should be BK : book space. Okay, there we go. So here, the person doesn't have any prefix, which means that's the default namespace. So now when I have title without a prefix, that means it's in the person namespace. And the only time I use the prefix is when I want to disambiguate. So I've created a prefix for book, which you can kind of think of as the secondary namespace. And then here I want to show that I'm talking about the title in book, not the title in person. So by default, title and name and person are all in the person namespace, and we don't provide a prefix there. And then because this is the book namespace, I have to put that prefix in. Okay? So, it should be pretty clear you can only have one default namespace in any given document. Okay? So here we go. No prefix on the default namespace. And then these nodes use the default. And then we go on from there. Sorry about that. Okay, let's see. You don't have to declare namespaces on the root, although it's common to do that. And it's possible to use prefixes on attributes, but in practice that's usually not done. One thing that's a little confusing about namespaces is the URL doesn't have to actually contain any actual document. It's not like the parser checks it. It only serves, like in the case of the Java libraries, to create unique identifiers or references for items within the XML documents. Okay. We saw, just like in HTML, that we can have special characters, and we didn't cover this, but in the XML document, you can have what's called parsed data, PC data, and that's basically where you're telling the parser to ignore this. So I can have binary data in the document. We're not going to end up using that, so we don't have to worry about that too much, okay? But to quickly give you an example, if I had JavaScript code, for instance, in my XML document, that would throw the parser off, and so I'd have to put it in a PC data section so the parser would ignore it, okay? So the short here is that for the special characters, we use the character entities like we've seen before. So the ampersand, the less than, the greater than, the double quote, and the apostrophe for the single quote, okay? So this is going to be more of a problem here in the XML than it is in the HTML. So you'll have to use those. Okay. It's possible to embed the document type definition right in the document. That's not very reusable though, so usually it'll be an external reference, and we'll use a URL or an external file for it. Again, we're not going to worry about this part of it. I'm just going to show you the syntax for linking the DTD and the schema, but we won't worry about creating those and how they are read. That's really an advanced thing, and I generally in my work I never encounter that, so I don't worry about it. So here's an example DTD that defines a memo, and basically you can see that the DTD is not in XML. It's in an older markup that comes from the SGML. And so you can see here that we have a square bracket that begins and ends here. That forms the body, and then these are all the elements. So it has a memo element, which has to, from, subject, and body child elements. And then we define the to, from, subject, and body. Okay. Again, you don't have to worry too much about this. Finally, we have actual data here. So here I have a memo. It has the to, the from, the subject, and the body fields. Okay? If we wanted to externalize this, we'd have our XML declaration, then we have a doc type, the name of the doc type, and then memo DTD, which is the file name. His system indicates that this is a local DTD or file that's on the system, in the file system. And of course, this you should recognize from HTML indicates that it's in the same directory. Okay, again, we're not going to use these too much. You don't have to worry too much about this. what is going on now is I have my memo in an external file, and all the memo documents can use the same thing now. And so I don't repeat that in each file. Here are just some ways of doing the system identifier. So you can use a local file reference, you can use the URL, and here if it's in the same directory, the file reference just becomes the name of the file. So these are really the same. You don't have to print out the file path though. So again, the DTDs define the rules for creating XML documents, and we can use them to validate that a document follows the rules, which means that it's valid. Schemas are used exactly the same way. The difference is the schemas came later. They're written in XML as opposed to some other older markup, so you can manipulate them with the same XML tools. Today, if you're ever going to need something like this, you should use a schema, not a DTD. The only reason we still use the DTDs is some of the older standards that we still use were defined with them. Okay? Let's see. So if we have a schema within the root element, we simply say schema location equals URL. I've already shown you how we use the doc type to connect the DTD to the document. Okay? So if you do need to use one of these, the easiest way to do it is just to create a sample document and then use a tool like Visual Studio to create the schema from it. You really shouldn't create new DTDs. They're legacy. We only use them for the important standards. We don't create new ones. We use schemas instead. The schemas are more powerful, and you can be more specific when you define the documents with them. They're also in XML, so they can be manipulated with XML tools. Okay? Okay, just some practical notes before we end here. You're going to be learning to use XPath and XSLT to transform XML documents. And we're also going to be learning the structured vector graphics, SVG, which is an XML language for putting these graphics into web documents and in standalone files. And you're going to need to know how to use the namespaces and the prefixes for these two things. Okay, so that's why I mentioned them here. All right, let's take a look at a practical example now. Let me save this so that I'll give you the latest version with the fixes I made. And I'll have to get that up in Blackboard for you. I've already opened NetBeans. And this is version 8. It doesn't matter. 8 is this is an older thing, so even an older version will work. It doesn't really matter. So I'm going to go ahead and create a new file. This won't be in a project. And notice I have XML, and then I have XML document, XML schema, DTD, entity, XSL style sheet, XML parsed entity. I'm not exactly sure what that last one is, but we want XML document, and then later on we'll do an XSLT transform. So we'll play around with Visual Studio and see how good it works for that. So now I'm going to go ahead and give it a file name, and I'm going to create this today on my temp drive. So I'll just go ahead and change the directory there. And whoops, it should be ctemp, not cusers temp. Sorry about that. And then let's see, we'll give it a name here. And this is going to be my book list. And I already started to play with this a moment ago. So let me just change the name to books, because I already have a file there and I don't want to stop the video and mess around with that. Okay, so books. All right, now, well-formed document, DTD constrained document, or XML constrained document. So you should understand now what these mean. The well-formed document won't have a DTD or an XML schema. These two are documents that are using some existing standards. So we're either going to use a DTD or an XML schema, and then it'll ask you which one to use, and it'll put that into the header and link it in. So we're not doing that, so we want the first one. and that's what we'll generally use. So we'll hit finish, and this is going to come up. Here's my header. It's using the default UTF-8 encoding. That's all right for what I'm doing today. We can get rid of this. Notice this is a comment, so we can get rid of the comment here. And then it's kind of funny because it gives you a default root, and I want to change that right off. So this is going to be books, and I'll come down here and change the equivalent closing tag, and there we go. Okay? All right, so now I'm going to create a list of books, and I'll probably just do the first one here. Maybe I'll do a couple so you get the right idea. So we're going to have a book element, and then within that I'll have obviously a closing tag that matches that. Oops, I made a mistake. I want it to be, it is case sensitive. I'm not sure if I mentioned that or not, but everything is case sensitive here, okay? So basically a single book, my books will have multiple books, and then a single book will be in a book element. And so the book element is going to have a title, and you can see that as I go, I'm going to go ahead and create the closing tags here, okay? Let's see, let's leave this on one line. So let me just go ahead and take that back. Harry grows up. I'm just going to make up some books as I go here. And we'll have an author node here. Author J.K. Rowling. I'm real fond of Harry Potter, as you know. And let's see, Harry grows up, J.K. Rowling. What are we going to have? What else? Well, we should have a publisher. And this is kind of a little joke here because Samuel Weiser is a publisher of occult books, not the Harry Potter books. And then, so let's see, we have title, author, publisher. We should probably have a copyright date. So copy, whoops, copyright. And I guess I'll make everything lowercase. Here we go. And then, let's see, we'll say she just wrote this 2015, okay? And then, let's see, that looks pretty good. Okay, so now that's one book, and so I want to add multiple books here into my books file. So I'm just going to go ahead and copy this, Control C, come on down here and paste in couple more books. Okay, so now I have 3 books in the file, and I'm going to go ahead and just tidy up the markup there. I like to keep my markup neat so it makes it easier to read the content here. Okay, so Harry grows up. Let's do a few more of her books. So Harry Potter and the Sorcerer's, don't think I have that spelled right, Stone. Oh, that's the Philosopher's Stone, isn't it? Yeah. Okay, we can leave that, and we'll make this, I have no idea when that actually came out. That's all right. And then let's add one here by a different author. Magic in Theory and Practice, and that's by Aleister Crowley. His name is Crowley, not Crowley, like our buddy from Black Sabbath thought. I'm going to say this was published in the 30s. I don't remember really. Okay, so now my XML document contains 3 books. And I'll go ahead and it's been saved by NetBeans. I don't need to save it. And I don't know if I have any validation tools in here or not. Let's see. Well, you know what? I'll come back and show you that later if we have that. So I'll have to do some research on that. You can use the validation in Dreamweaver, just like you did for your HTML. Excuse me, having a little bit of a frog in my throat this morning. Okay, so just a couple of things. Notice that the one root element contains everything else, books, and then each book has the same structure. And that's not necessary, but it's common to do that. So here we have, and certainly each one would have a book, and then we have title, author, publisher, and copyright. So most of the time the XML will be very regular like this, where each record will have the same kinds of elements and child elements. And a lot of times when I do this example, students don't get that, and they'll do something like this, where they'll make this book 1, book 2, book 3. Don't do that, okay? So the idea is that I have a collection of books, and they have the same structure. Now, you can see how I could do the same thing with a Excel document, right? So let's real quickly, I'll just show you that. So if I go over here, where the hell is that? Let's see, Excel. And let me minimize that so I can kind of see here. Let's see. Oh, okay, here's what we're going to do. Let's go ahead and put those next to one another. And so now if you look at this, basically I could have title, and then author, and then publisher, and then copyright. And the same information in Excel would look like this. So the first book would be Harry Grows Up in the title field, and then the author, J.K. Rowling, and then Samuel Weiser, and then finally 2015. Okay? And then the next book obviously would be this one, Harry Potter and the Philosopher's Stone, etc. So you can see how this same kind of data is represented here with 2 different representations. And in this case, each book is a row in the style sheet. The first row has all of the column headings, or really the titles for the data fields, okay? So again, I'm kind of assuming that you know what a spreadsheet is and how it works, but it's important to kind of look at how the XML corresponds to the representation of the data when it's in that spreadsheet format, okay? Now, obviously, you can see that it took a lot more space to write out these tags in the XML, and that's one of the criticisms of XML, is that it gets kind of bloated when you have a lot of data. But it's also got the advantage that it's sort of self-documenting. This is very readable. I can understand exactly what everything is, and it works pretty well. Okay, I think that's probably enough for now. I'm going to call it a quit on the first vid, and then we'll talk about some format issues here in the next video. So again, I hope you're enjoying the videos. I hope they're helpful for your learning. This XML is a very powerful technology. We haven't really but just scratched the surface at this point.